Alright, welcome back guys. We're going to try to get through the rest of this today. Alright, so we made it to objective 3 here, and we're going to be doing a lot of the same thing, converting from one unit to another, except we're going to be using some metric units. Okay, so what is a metric unit? A metric unit is a unit that's based on 10. Okay, and so for example, it's not really based on 10, but the metric system allows us to have different units as multiples of 10. So for example, a meter is a unit of length, and then you can have a decameter. You can have, let's see, I'm not sure what it would be for 100 meters. And then you could have a kilometer or a kilometer. So this prefix right here, kilo, this refers to 1,000. So a kilometer or a kilometer is 1,000 meters. Going the other way, smaller distances or smaller units of length, you can have a decimeter. You could have a centimeter. That would be like 100th of a meter. You can have a millimeter, and guys, it can just keep going. You can have a micrometer, which is a millionth of a meter, or even a nanometer. Okay, that's really small. So that's what's kind of interesting about the metric system. But anyway, let's take a look at example number 9 here. So what we want to do is we want to convert the distance of this race, which is 26.2 miles, to kilometers. Okay, so we're going to start like we always do. We're going to say 26.2 miles. We're going to put that over 1, or multiply by our conversion factor. Now some of these you may need to look up. You can just do a quick Google search. So you could type, or any sort of search, it doesn't have to be a Google search, so you can type in here kilometer to mile, okay, or miles, or in the reverse order, it doesn't matter. Okay, so if I come down here, this says that 1 kilometer is equal to 0.6213, etc. miles. Okay, I'm just going to say that it's equal to 0.62 miles, and that's what I'm going to put in the notes. Okay, so this is our conversion factor, the fact that 1 kilometer, and this is the way it's abbreviated, is equal to 0.62 miles. Now sometimes, depending on the order, you could also say that 1 mile is equal to, I believe it's 1.41 kilometers. Okay, so either conversion factor will work as long as you get your units right. So I want to cancel miles, so that means I need to put my miles in the denominator, and I need to put my 1 kilometer in the numerator, so that my unit miles will divide out and will multiply straight across again. We're going to be left with kilometers, which is the desired unit. 26.2 times 1 is 26.2. We've got some stuff to multiply in the denominator. 1 times 0.62 is 0.62, which means, guys, we've got one last step here. We need to actually divide. So we'll say 26.2 divided by 0.62. And you know, okay, so we end up getting, I'm going to round to 1 decimal place, so I'm going to call this maybe 42.3. 42.3 kilometers. Okay, kilometers are smaller than miles, guys, so when you're converting the number of miles to kilometers, you should get more kilometers. All right. Okay, so now let's talk about converting temperature between two scales. So the scale that we commonly used in this country is the Fahrenheit scale, although we use the Celsius scale as well. The Celsius scale is actually nicer in that 0 degrees is designated to be the point at which water freezes, and then 100 degrees is designated to be the point at which water boils at sea level, okay? Because sea level does affect the boiling point of water because it has to do with pressure, but in any case. Now with the Fahrenheit scale, it's a little bit weirder to me because water is designated to freeze at 32 degrees Fahrenheit, and then it's designated to boil at 212 degrees Fahrenheit, and again, that's at sea level, okay? So you can see that the Fahrenheit scale is spread out more. From the freezing to boiling point, there's a larger distance on the Fahrenheit scale as opposed to the Celsius scale. So each degree Celsius actually represents more than 1 degree Fahrenheit. All right, and then this is a link right here, guys, to another video, kind of the history behind the Fahrenheit scale. So if you have those notes or the Word file, you can click on it and you can watch this video. It's pretty interesting. But anyway, what we want to be able to do is convert between the two units of temperature, okay? And for that, guys, we're going to be using these two formulas right here. Okay, well, let me recircle this one because I don't want to write on top of the decimal. Okay, there we go. Yeah, so you're going to use this top formula anytime you want to convert from Celsius to Fahrenheit. See how this equation is solved for Fahrenheit? And then you want to use the second equation anytime you want to convert a temperature measurement in Fahrenheit to Celsius. And that's actually what we're doing with this next one. It says average human body temperature is 98.6 degrees Fahrenheit. So what would this be in Celsius? We're just going to focus on Celsius here. Okay, we're not going to worry about Kelvin. Kelvin is another scale. It's used more in like research. All right, so if I'm trying to go from Fahrenheit to Celsius, then I need to use this second formula. Okay, so I'm going to rewrite it real quick. Celsius is equal to temperature in Fahrenheit minus 32 divided by 1.8. Okay, and the 32 does correspond to the temperature at which water freezes in the Fahrenheit scale. And then the 1.8 just means that each degree in the Celsius scale is equal to 1.8 degrees in the Fahrenheit scale. But anyway, guys, what I'm going to do here is I'm going to take that 98.6 and plug it into F. So if I do that, I'll have C is equal to 98.6 minus 32. Whoops. And then this is divided by 1.8. So we'll do a little bit of arithmetic. 98.6 minus 32. And then we're going to take that and divide it by 1.8. And we're going to get 37. Okay? So 37 degrees. And you need to designate that it's Fahrenheit. Okay? Because if you just put degrees, we don't know whether that's Fahrenheit or that's Celsius. Alright. Alright, so next we're going to look at converting between currencies. Okay, so anybody that's traveled outside of the country and has had to utilize another country's currency, then you've had to use your dollars to buy that country's currency. And so to figure out, or to determine, how many units of that country's currency you can buy, we use, or they would use exchange rates, okay, currency exchange rates. And guys, these change constantly, okay? That's why you might hear in the news or read an article about the dollar gaining strength. Okay, that just means that the dollar can buy more currency from around the world. or if the dollar loses value, then that means it can't buy as much currency. And a lot of this has to do with trade and the demand of products that the U.S. produces and other countries produce, etc. But anyway, here's a little chart like you're going to see in your homework. And I want to explain this for a second. This chart contains your conversion factors. Okay? But the way you have to read this is, like for this first row, this means that 1 British pound is equal to 1.624 dollar, or hold on a minute. Yeah, this first one right here means that 1 British pound is equal to this many dollars, okay, this many US dollars. Now if you read it the other way in the second column, this says foreign per dollar, okay? So this means that $1 will buy this many British pounds. Okay, so I like to use the first column. That's easier for me to kind of wrap my head around. Okay, so just remember, like in this next one, 1 Canadian dollar will buy 1.05 US dollars. Okay. And then 1 European euro will buy 1.320. Let's see. 1 Japanese yen will buy this many dollars. Okay, so it's a little over a cent. So one Japanese yen isn't worth a whole much. And then one Mexican peso will buy about close to 8 cents. Okay. All right, so this is the column that I prefer to use. All right, so let's look at an example. So it says a French department store charges 45 euros for a pair of jeans. And so the question is, what is the price going to be in US dollars? So we're trying to go from euros to dollars. So you're going to start with 45 euros. You're going to put that over 1. And then you need to find the column and row that equates euros to dollars. Okay, so it's going to be this third row. Okay, so my conversion factor is going to be that 1 euro is equal to 1.320 dollars. And I'm using the dollar sign to denote that this is dollars. Okay, so if I write that as a fraction, that's my conversion factor. All right, so what do I want to put where? Well, I want the euros to cancel. So I'll put the 1 euro on the bottom, and then I'm going to put the $1.320 in the numerator. And so now my units, euros, will divide out, and that's what I want. And I'll multiply straight across again. So, well, I have to do this in my calculator. 45 times 1.320, that is 59.4. Now, all we're going to have in the denominator is 1 times 1, which is 1. So I'm not going to put a denominator. So my resultant unit is going to be dollars. So 45 euros, or jeans that a pair of jeans that cost 45 euros in dollars would cost $59.4. Okay. All right. And you can see this is rather old. This is from 2013. Like I said, these change constantly. In fact, a lot of people buy and sell currencies. All right, let's look at example 13. Example 13 says, gasoline sells for 1.5 euros per liter in Bonn. I believe this is in Switzerland, if I'm not mistaken. And so the question is, what would the price in US dollars per gallon? Okay, so you know over here we buy a gallon, we buy gas by the gallon. In most other countries in the world, including Canada, gas is purchased by the liter. Well, the liter is the metric unit of volume, and the gallon is the English unit of volume. Okay, so, or at least one of them. All right, so what we're doing here, I'm going to start off with what I have. 1.5 euros per liter, so that means 1 liter goes in the denominator, and I'm using a capital L to denote liter, okay? All right, so I'm going to need a conversion factor. Now, this is a two-step problem because we're trying to convert euros to dollars and also liters to gallons, okay? Well, we already saw what the conversion factor for euros to dollars was. This was given to us above, so I'm going to rewrite it down here. So 1 euro is equal to $1.320. And I'm going to go ahead and plug that in. So I want my euros to cancel. So I'll put this in the denominator and then my number of dollars in the numerator. And I'll go ahead and divide out the euros. Okay. Now that's going to leave us with dollars per liter. So now we need to convert liters to gallons. Okay. So I need another conversion factor. And so again, for this, I'm just going to do a search. Now in your homework, you'll have access to a little chart that'll open up, so you can use that. But well, you can just type it in. You can say liter to gallon. And so you could use this. This says that 1 liter is equal to, I'll carry this out to maybe 3 decimal places, 0.264 gallons. Okay, so 1 liter is equal to 0.264 gallons. So that's my last conversion factor. Now, I need to orient it such that my liters cancel. And notice my liter unit over here is already in the denominator. So that means I need to put this in the numerator. So 1 liter in the numerator over 0.264 gallons. And so if I do this, my liters are going to divide out. And now, guys, I'm going to have dollars over gallons. And I just need to multiply straight across, okay? All right, so we got 1.5 times the 1.32. And that's going to give me 1.98. $1.98 per. Now I've got several ones, and then I've got this decimal. So it's just going to give me the decimal, 0.264. Okay, so we can divide here. We need to divide this out. So 1.98 divided by 0.264, and we're going to get 7.5. So $7.5 per gallon. So you can see that's rather expensive, isn't it? Okay. Gas in a lot of the world, guys, is a lot more expensive than it is in the U.S., especially in Arkansas. Arkansas is one of the cheapest places in the country. All right. So as you can see, we had to use a couple conversions there, and this is not uncommon. All right, well, we've got a couple left, and then I think I'll stop this video. And then I may do one more in which I look at least one example from your homework. There's one problem in there in particular. It really gives students fits. All right, so let's look at this last two. So it says, suppose a car travels 25 miles every half hour. So this is, you could look at it like this, 25 miles per half hour, okay? Now I have of an hour is the same as 0.5 hours, okay, as a decimal. So I'm going to remember that. And the question is, determine its speed in miles per hour. Well, let's start with what we're given. We're given 25 miles per half hour, okay, so you got to put 0.5 times. Now, I need to use a conversion factor. Now notice, we're going from miles per half hour to miles per hour. So in other words, we're trying to go from how many miles can you cover in a half an hour versus how many can you cover in an entire hour. Alright, so I'm going to leave the miles the same, but I need to cancel my hours. So my conversion factor is this, the fact that 1 hour is equal to 2 half hours. This is kind of a weird question, I know. In fact, yeah, okay. Oh, wait a minute. Now let me redo this one because I'm going to I actually converted that up here. I don't want to do that. So 25 miles per every half hour. So 1, and I'm just going to write it, half hour. Okay. So we want the half hours to cancel. I want to keep the miles. Well, 1 hour is equal to 2 half hours. So I'm going to put my 2 half hours in the numerator and my 1 hour in the denominator. So now you can see that the unit half hour divides out. And so we're going to be left with miles per hour. And we've got to do a little bit of multiplication. 25 times 2 is going to be 50. The unit is miles per hour, okay? Because in the denominator, 1 times 1 is just 1. Let me rewrite that 0 for 50. Now, one like this, guys, you could probably determine the solution intuitively, okay? If you can cover 25 miles in half an hour, then if you double that, that's the number of miles you're going to be able to cover in a full hour. All right, we've got one more. Okay, the last one here. This is a very practical problem. It says you can buy shampoo in a 5-ounce bottle for $2.49 or shampoo in a 14-ounce bottle for $9.99. So it says find the unit price for each and determine which is the better deal. Okay? Well, you can only determine which is the better deal by finding the unit price. If you could determine how much per ounce each of these items is, then you could compare the two and figure out which one's the better deal. You can do this when you go grocery shopping as well. I do it. Okay, so if you're looking around for, say, a can of tomatoes, they may be at different sizes, but you can look at the sticker on the shelf and it'll say price per unit, and you can compare them that way. So sometimes, well, most of the time actually, the larger quantities have a smaller price per unit. That means you're getting more for your money. Okay, so how do we find this unit price? Okay. Well, it's going to be the price divided by the quantity. And this quantity could be in ounces, it could be in pounds, it could be in grams, whatever. Okay. All right, so for the 5-ounce bottle, the price is $2.49, and the quantity is 5 ounces. And so we're going to divide this out, and that'll give us the price per ounce. So $2.49 divided by 5, and Okay, because we're talking about money, I'm going to round this to 2 decimal places. So this 8 would bump that 9 up to a 10, which would bump that 4 up to a 5. So this would become 50. This is like 50 cents, or in other words, 0.50 which is the same as 50 cents per ounce. Okay. Now, what about the other bottle? It costs $9.99, but you get 14 ounces. Okay, so we'll divide these out as well. All right, so $9.99 divided by 14 ounces. And I'll round this to 2 decimal places, so this would become 0.71. So in dollars, 0.71 or 71 cents per ounce. Okay. So now that you know what the price per ounce is, you can determine that the smaller bottle is the better deal. Okay. And you have a homework question like this one as well. So, do it just like this. Even if the unit price wasn't listed, I think now it's a requirement. But before it was a requirement, or if sometimes the unit price isn't listed, you can always calculate it yourself. So anyway, that brings us to the conclusion of the notes, the examples in the notes, guys. Like I said, I may do one more video, a short video, in which I work out 1 or 2 homework problems for you. And then that will pretty much conclude chapter 2, okay?